All right, so if you were in my class yesterday, or the little presentation I had yesterday, welcome today again. We're going to go over Dredgepack reporting. Sometimes I wonder what that is because it's different for everybody. There's a few PowerPoints I'll go through, but then I'm going to go right into the software, and then I'll kind of show you what the dredgers out there are currently doing from what I see and how they're presenting their material that's collected in Dredgepack. And we'll go through all that stuff. What we're collecting on the dredge, how to process it, and how to run a quick volume against it, and how to plot it. I think that's everybody. At the end of the day, the boss probably wants a PDF in his inbox showing you where the dredge has been. Very important. So we have these different tools, several different tools that we can use. Dredge statistics. I'm just going to breeze through these because I want to put my hands on the software. I think it's more helpful. Dredge statistics. All of this stuff is found under the utilities menu, dredging utilities, and you'll find this program here. And what it does is it takes one or two data sets, a pre-dredge survey and a conditional survey or an after-dredge survey, and plots the distribution of depths so that you can see the consolidation of depths across the XYZ file. And then it'll give you your standard deviation between depths, your average depths for the pre-survey. And it tells you, most importantly, the percentage of depths above grade. So for instance, this one's just got 82.8% of the depths are above grade. So pretty much the whole area is above grade. Okay. So that's for a pre-survey. If you load a post-survey in with it, it'll compare the two XYZ files, or the two surfaces, and it'll tell you how much has been removed and what's remaining statistically. Does anybody use this program? Okay. It can be helpful just to get an overview of the depth data statistically, and you can confine it to a limit here. You can confine it to a border file or a line file. There's a video. It'll walk you through it if you want. You guys have all of these on the flash drives that we gave you. Then we also have the matrix reporter. This is an old slide, and some people use it. And what this is a database. It's a database of all of the matrix files daily that you load in. So that what it gives you is, it gives you the date and estimated cubic yards removed. Because the matrix file is all cell-based. So if you start the database with your pre-dredge survey and then load all subsequent days matrix files, it compiles all the cell information inside the database and comes up with the estimated cubic yards removed.
So we have a lot of clients that I use that all the time.
Do you?
A lot of people really like it. The problem is the cubic yards removed is almost like most of the time that number's not reliable at all.
That's
and
right.
I end up like whiting it out. And I said this at one of the HYPACK presentations. If you can customize that anyway, like what I do is I do border files for what we've done. So I give them like area cover, because at least that, because if you start telling them volume numbers and it's not right, then they lose their minds. But if you just say, okay, we covered this area, project management stuff, they get an idea for progress without, but there's no way to customize that.
Right.
So I use whiteout in a PDF.
Yep. So hopefully when I'm fixing to show you what we've talked about before with the single beam editor, I'm going to take that one step further and show you kind of how to plot that and color by day.
Oh, that was cool.
So it's kind of a different way to get to here.
Okay.
And I'm not saying it's more accurate because the volume number is derived off of the accuracy of the calibration of your ladder. And how you ran the data through the, it's a matrix file. So yeah, it's just basically how the cutter tool interacted with the matrix file.
Yeah, yes. I mean,
that's it.
if they did the survey like a week before or something, and there was a big storm, all of a sudden all those numbers, could be meaningless. So.
Right. So that's all the PowerPoint I'll be doing today here. My screen is a little small. Can you guys see that? Oh, on my end, it's pretty small. It's confined. Let me try to change the resolution. I didn't anticipate this. This might goof things up. Yeah, I'll just leave it the way it is. It looks pretty good up here for you guys, right? Okay.
Yeah.
Okay, so Travis with Florida Dredge and Dock has given me this project. It's Wiggins Pass down in Naples, Florida, and they just started dredging, a few days ago,
Yeah.
a week ago or so. So just to give a little background on these files and how these files were collected, these are the raw data files from the dredge. So you see in the data display that you're logging, it's saving a raw data file, kind of like single bean. So they're over here. They're over here under raw data files. Okay. These files right here go to the raw data folder. Open and explore. It'll take me right to where that file is. Okay. So this is in the project folder. Call your dredging, and then the raw file. Let's talk about what's in these raw files and why we're able to use them. So I'm going to click on raw 01/04/2020, so January 4th, 2020. I'll open it in Notepad. So that was a right click on the raw file, and then I'm going to open it in Notepad. I'm going to change the font just a little bit. Drive 16. You're collecting a lot of data here. Okay. So when you start logging a raw file, it's going to write the header starting up here with FTP. It's going to tell you the version. Okay. Good way to know what version of survey you're using for troubleshooting purposes. This INF line right here, this is the information that you put in the survey program under options, project information. The boat, the surveyor, and all that stuff goes into the information line. Then you have all of your geodesy information and your projection. It goes all the way down to the geoid model. And then you have your horizontal and vertical units, which were in feet. By default, HYPACK is in meters. So the multiplier is 0.304 horizontally and vertically. And then we have the TND, which is the time of day that this file started logging. And it started at 07:53 on this date right here. Then below this, these are all the devices that we have loaded into HYPACK hardware. So you'll see over here we have inclinometer DLL, we have a cut fill driver, we have the spud, and we have a pitch and roll driver down here. Okay, so it lists all the drivers. And the important thing about these devices is the device number. So device number 0 is the inclinometer, device number 1 is the GPS DLL, device number 2 is the cut fill, device number 4 is the spud, it's disabled, and device number 5 is the pitch and roll. Also tells you what line file was loaded in the survey program as well. So it's Wiggins line set.lmw. It goes on further to define that line in its coordinates by these PTSs. So I have PTS, the coordinate. We'll explain it at plenty of time, so sorry if this is the nuts and bolts of it, but I want to show you how it works in our software. So there's 5 points that define this line, PTS, and then we have the LBP, which is the line beginning point. So every line has an origin. The best way to know what the origin of the line is if you're looking at it in HYPACK on the screen, it's the label side. The side that has the stationing is the beginning point of the line. I say that because you can arrange the data display to display DEL or DMG, which will tell you how far you're down the line. Distance made good, distance along the line. And then we have end of line information, and then it says the user. So when we get these raw files, we can tell who's using the software and who logged it. And this is the key information. So we log all that as well. All right. So to get down to how we're using this in our software, is we log all of the data for those device drivers, for the inclinometer, for the GPS. Just to give you a little nomenclature here, the EC2 is an echo sound, a depth, and if it's an EC2, it's got 2 frequencies. The inclinometer DLL is capable of logging not 2 frequencies, but 2 depths. Because it serves a function of depth, but it also serves a function as draft. And that would be another thing that it logs. So EC2 from device number 0, that was up in the header from the GPS, we have a timestamp right here. And that timestamp is based, this depth has this timestamp. And then we come down here and we have the heave, pitch, and roll from device number 5 with a timestamp. And we've got heave. You just have pitch and roll on the dredge, so heave is 0, and then we have pitch and we have roll. And then come down here, we have position, POS from device 0, with the XY that was computed by the survey program. GYR is heading, the heading value, and then it just, I guess I'm leaving one out, TID. TID from device number 1 has the timestamp and the water surface elevation. So if you want to see what the tide was on a particular day, and you don't want to open it in the editor, you can just pop one of these babies open a notepad and look for the TID record, and that will show you the water surface elevation real quick for that moment in time. Okay, so that's a raw file. They're pretty simple. You can open them up. Okay. So what I see a lot of people doing is taking this stuff through the single beam editor, these raw files through the single beam editor. And that's how they're doing a lot of the reporting for tracking the progress of the dredge. Once we get it into the editor and get it back out, there's some things that we can do, but let's start in the editor. If we go up here to processing, we have single beam editor 64. With the open folder button, and we'll browse to the raw folder. Now I've noticed back over here that the 2 files that I want to work with are this. I would change this in the future going forward, the naming convention of the raw file. Under in survey, under options and project information, I would probably go to I forget the name of the type of line, the file naming convention, but it's something a little bit more specific. It'll have the line name, it'll have the time and the Julian date, so that when you go to the raw folder, you can differentiate all the different files by date and time, other than having just all of these line number and time.raw names. But if I keep that in mind, and I want to grab the 753 and the 902. So I'll change the file of type. So I'll select the 753 and the 902. Okay. First thing that pops up is the survey tab. Not much you have to do here. This is not a single beam processing class, but you can kind of just leave this stuff default. Choose elevation or depth mode. You can kind of advance through this as well, because the dredge was using RTK tides, so we had a water surface elevation as a TID record in there. So if you wanted to, you could add a tide file. The important tab is right here, this devices tab. This is where you set up where you're going to pull all the information from. So in this instance, we have the navigation device. It's not the GPS that we're concerned about, because that's on the body of the machine. We care about where the cutter head is. So we're going to choose inclinometer as a navigation device. Our tide device is going to be the dredge GPS, and we're going to have RTK tides checked. And it has the offsets. It's a good place to check your offsets and make sure they're right. So this GPS antenna is port of the trunnion, and it's back 16.5 feet from the trunnion pin. Then we'll apply an MRU, pitch and roll. The sonar, it's not really a sonar, it's an inclinometer computing the depth. So that'll be inclinometer as well. And then heading inclinometer. So those are the three things you want to make sure. So in your case on the Equina, it's going to be the drag arm. It'll be the drag arm driver for the heading, the sonar, and the navigation, so that you can plot. And unfortunately, you have two drag arms.
I have to pick one of them, right?
You'll have to process them twice because you have two drag arms. Yeah. And you'll hit OK. And I'll just make sure over here under processing, I have this apply pitch and roll corrections selected. And then I'll hit OK. Okay, so something that I noticed here is it looks like they were transiting over here with these track lines. And I can tell if they were transiting by looking at the depth. So I can throw this in 3D space and rotate it around. And it looks like while they were under tow, they had the ladder up. Okay. So this is just like working with single beam data. You can cut that out. You can cut that information out. So we've got the tools over here where we can select a box and delete that data. We don't want to turn that into the owner. Kind of just clip that stuff out. Okay. So now I have these two sets of data. These 2 days, it's hard to differentiate which day is which, but if you draw selected files only, this is the 902 file and this is the 753 file. Looks like it kind of covered the same area. It just kind of swung in the same area. Okay. So from here, just making sure I don't have any spikes, anything out of the ordinary. These yellow X's are flagged soundings. And it looks like their ladder was up a little bit here. It looks like they were swinging with the ladder up. And it's flagging two or several points that fall within my filters. So if you right click in this window, you can get to the search and filter options, and it's filtering based on a minimum depth. So it's going to remove anything minimum of 3. So if I apply that filter, I can get rid of those depths that got flagged. And now I've got what I know to be a good set of data. Okay? So what's important knowing for a dredger is depth over time. What was he doing all day long? And I can see the depths on the screen, but if I look at it in a profile view, I'm going to draw selected files only. I'm just going to draw one at a time. Okay. Wow, that looks really strange, doesn't it? Because the way that we're looking at it here, it's scaling everything depth over distance, and because the cutter head is sweeping through the channel, it doesn't do a good job displaying it. So you got to choose depth versus time for a dredge sweep. Now we can see, starting at 902, we have all the depths going all the way to 1540. So you can kind of see, and I wish I could change the screen resolution, because if I did, it would stretch all this stuff out so it would look a little more smooth. But this is what happened during the day. So I clicked over here, saying, okay. So I've got this, I've selected this point right here, because it looks like at this point in time they raised the ladder. So it tells you down here at this coordinate, this was the depth, and it doesn't give me time. The old editor used to give me time. Down here, I don't see time.
Do you have like a spreadsheet window?
Absolutely. Yep. So that's one of the important windows. The other one is, you see a lot in these dredging contracts, the owner requires you to turn in a spreadsheet of time, X, Y, heading, whatever parameter they put in there. And the spreadsheet is where you'll want to output that information. So you just go over here to spreadsheet, and then you have all the fields. We can remove this GPS elevation. Corrected depth, draft, and have draft. Okay. So you have all of these fields that you can add. So one of the formats I usually see is time is usually the first one, and then raw depth, and then I'll usually put tide here in the middle, and then corrected depth, because if you take raw depth, add tide, it gives you the corrected depth. And then we'll put date. Heading. So something like this. Okay. So once you have the spreadsheet compiled, you'll hit export. You can export a single file or one file per line. So I have 2 files loaded. So if you wanted to do each day as a separate file, that's usually what they require, is 1 file per day. You could bring in a whole week's worth of data and set it out as one file per day. Okay, pretty simple stuff so far. Okay. Does anybody use this for single beam survey? So it's kind of the same thing. You're processing the dredge data just like you would a single beam survey. Okay. So really all you have to do next is save this information out, save survey. And I would encourage you to save it in a couple of different formats, 2 separate formats. I would back it up right here, HS2X. That way, if you ever wanted to open up that day's data again, you wouldn't have to run through, read parameters, and do any editing. You could just simply open this up, and it's just as if you just left the program and came back in with that same set of data. Okay? And then the XYZ file. You'll want to export the XYZ file. So we'll do that. And then XYZ. Here's a third option here, and I'm going to go over why I'm going to click this button. This is the old way that we used to save single beam data. Does Is anybody familiar with the multi-beam format, the HS2X files? The HS2X files are our new single beam files. The old school way we used to do it was all format files. So if you save it out in the old school format, you could open it up in the regular single beam 32 program. You can't open the HS2X files in the 32 program. So I'll go ahead and save it there as well.
Yeah, I remember when the 64-bit came out, the survey or stuff like this, you would save it. It would go to your edited folder, but when you open the file, when you go to your edit folder, it would read still as raw. You know, when you pull up raw data, it's raw, the date, real date, whatever.
Right.
But whenever you would edit it, before in the 32-bit, it would be EDT and then the file name.
Right.
Is that still?
It's a
So
good
now
question.
Is it still saving it as raw on the editor, or is it ready?
Let's see.
Oh, is it?
Yeah, so this one that just got saved, it's got the same name, underscore EDT, and then I had a prefix in there,
Yeah.
and then .hs2x. That's the way it's going to name that. Now, with the edit file, it's just .edt.
Yeah. No, I'm saying like before, like if you see your log ones,
Mm-hmm.
it says EDT when single beam before it came out, it was saying RAW, but it was still being under the edit folder.
Oh, I see. Okay. Okay, so they must have changed something. Okay.
I think it would do that if you had a tag when you save the file. If it didn't see you saved it under a particular name. I could see it not use that name when it saved.
Okay.
Same as raw, that's strange.
Yeah, that's strange.
Christian, do you typically have guys use the entire day in one file? Seems like kind of good.
In this program, one
Well,
raw.
when they're logging data, you got one file for the entire day, 7 hours a day.
Yeah, that's great.
Yeah.
Yeah. Travis has this set up nice where it's not too much data. He's got limit the update rate for all of his devices, or I'm sorry, not the limit the update rate. He's got his limit the recording rate set on every 3 seconds. So inclinometer is probably a 10 hertz device, GPS is probably 10 hertz, but that's not what's being saved to the raw. Since it's a dredge, 3 seconds is good enough. So, you know, one day,
Just seems like a lot of data if you had to pick up the files.
so each day is 4 to 7 megabytes. I'm of the opinion that I like to record all the data. I'd rather have more data than not. And the single beam 64 program is lacking one of the features that the old editor used to have, which is a pre-sort function. So when you're looking at your contract, I think we were looking at one of Travis's contracts yesterday. It said you have to turn in data to the owner no more than 3 minutes apart for each X, Y, Z of the cutter head. So, you know, if you give them a huge file that's 20 megabytes that contains 10 hertz data on everything, if he didn't limit the recording rate in hardware, we'd have a lot more data here in the editor. I was talking with John, and we're gonna put the pre-sort routine in this single beam editor so you can collect the whole data set and then reduce it down in the editor, like the old single beam. So that's a long answer to your question. So the short answer is collect all the data and let's thin it out later. Let's worry about that later. That would be my opinion. Okay, so we've got these files saved out. What's the next? What else do we do next? How do we report this? So I've got these raw files, and now I've got an XYZ. Let me change something real quick. I hate these 2 checkboxes right here. Anybody know what these 2 checkboxes do? In the control panel for HYPACK, if you have these 2 checked, these 2 checkboxes, automatic searching data files and project files, it's going to find any associated file and load it here in the list. So I like to control what is in and out of HYPACK, so I usually go in there and uncheck it, so I'm easily confused.
How did you get into that?
If you hit F9 on the keyboard, that'll open it up. Or if you hit this little hammer and chisel, this hammer and chisel icon, or you can go settings. That way I can remove all the XYZ files and just add the one that I want. Okay. I'm also going to add the edited files that I just saved out. These are these two EDT files or these HS2X files. So I can select those. See what I see here. So I just see a blob. We're going to fix that. Okay, because we can't tell what's what here. Got, you open this tree up. So I've got the two HSX files for my 2 days, and I've got a color palette over here, but everything's black. And why is that? Well, I've got one of two things working against me here. I'm either displaying just the track lines or I'm coloring all the soundings by black. If I right click on edited data files, I have enable track lines and enable soundings selected. So I know that probably it's the way that I'm displaying my soundings. So if I go over to the right hand side, I'm going to choose decimal point on mark, or I like pixels. Also, I'm going to color by depth. Okay. I'm going to make this a little prettier. This is a cheat code right here. I know you have your color palette set up for your operators on the dredge, and I wouldn't go on your dredge and change it because they would probably throw me overboard. But if I right click on this XYZ file, there's a cheat code down here, set palette range for associated palette. That's a mouthful. But what that will do is it will look at the min-max Z value in my XYZ and build the color table based on my min-max in the XYZ. So that it creates a nice pretty little color table for me. Okay, so this is a good way to look at it, color by depth. But we like to see color by day, because we want to see where we're at day 1, day 2, and we can do that right here in the HYPACK shell. So right here in the HYPACK shell, I can come back over to my display type and do color by file. And if I color by file now, I can right click on each one of my files and set the color. So this day right here is green, and this day over here, we'll make it red. So right here, it's really easy just to look at the screen and look at your files and see where you were at on those days, day by color. Is anybody already doing that? No? Is that helpful at all? Does that add any value to what you're trying to do?
How would you, I mean, what's the best way to export, like just, if you want to just print out a map of that?
Okay. That'll be the next thing. So I would probably just plot it out real quick with HyPlot. So I would probably do something like this. I would go to Preparation, Editors, and I would go down to the Plotting Sheet Editor. And in that Plotting Sheet Editor, I would set a predefined sheet size, 22 by 34. And then you have the scale up here, so 20 feet to an inch. Seems pretty reasonable for this area. And I would just move the plotting sheet around where I wanted to plot. Okay. So with this plotting sheet editor, when it comes up, you can move the plotting sheet around. There's a circle down here, it's a grip. You can move it around. You can rotate the plotting sheet by the opposite end. You don't want to mess with these corners over here, because if you do, watch what happens. it changes the dimension of your plotting sheet. So if you're trying to fit that to a nominal size piece of paper, it's not going to work. That's why these predefined paper sizes work, because notice I choose 22 by 34. It fills that in automatically for me. Okay. So I'll just save that out. And you'll go into final products and HYPACK. Notice you had a lot of SID files in there. And, the matrix is not too big.
Yeah, so close.
Okay, so this is your matrix file. Notice something. This is a little goofy. Programming's got a better explanation for it. See this right here? Wiggins MTX. So that's the matrix file that you're using. But HYPACK is open. It will actually create this other file inside your project, a .mesh file. And that's because the programmers draw things kind of different than they used to. So they take that matrix and create a new file because that's a file they can draw faster. So if you ever see that, that's what that is. That file gets deleted when you exit HYPACK. And then when you open it back up. So that's just some goofy information, but. Probably turn these SIDs off.
Is that why if HYPACK or Dredgepack crashes, closes out abnormally, the matrix isn't saved?
No, well, the reason that happens is because the survey program has the matrix open in memory, and then when it crashes, memory dumps and you lose it. But there's a backup. There's, you know, the
Yeah, oh, I
backup.
know, I use those
Okay.
a lot.
Okay. Okay. So
The next screen photos. So Christian, what you have enabled in the shell is what comes through in the file.
that's right.
So if you want to turn off all those line files, or you can turn on grid or something.
Right. So my soundings, I can use color by file, just like we did in the HYPACK shell. I'm gonna exit and come back in. You probably have more time at your desk to wait for some of these to draw. Oh boy, you do have a lot. Okay. Let's see if that draws any faster. Maybe it wasn't the SIDS. Okay. So just so we can see, I'm going to turn the matrix off. Okay. And this is what you can save out to PDF. You can do a direct save to PDF. That's the down and dirty. You getting something out of HYPACK with the progress of the first 2 days. You can pretty this up in the control panel, and you can add these custom title blocks. But I like this border. I think this New York core border is real good, because you can define this border with all these parameters inside each cell. You can add information, and we've got the Corps of Engineers symbol already, hard coded inside here, the new style or traditional. But if you have a company logo that you want to use, it'll take in a JPEG or TIFF file or anything. So Gator Dredging has a cool gator on theirs. They can customize their title block. But what that does is it makes a nice, neat little border around the whole plotting sheet where you can add notes. So that's one of, so taking the raw file into the single beam editor, kicking out these HS2X files, coloring by file, making a plotting sheet using HYPLOT is a good deliverable. What's another good deliverable to have? A 3D image? Would that be helpful? How would I do a 3D image out of HYPACK with what I've got? You can use Tin Model, or you can use the Cloud program. Cloud program is pretty quick. With the Cloud program, you can load that XYZ file that came right out of the single beam editor. How fast that draws. Then you can take and you can load background charts in here. So these are all the ones that are enabled. Okay. So here's your data over your matrix file, portion of your matrix file. Let me get rid of that matrix file. A little redundant. There we go. Remove. This might be. Okay. All right. So that's a little bit better. You can export this out to a web export. So somebody that does not have HYPACK can look at this data in a web browser. So it creates these two files right here, an HTML and this JS file. So if I open this link, now in the browser, I'm giving somebody points that they can actually rotate around and look at in their web browser. Okay.
What kind of file type was that again?
It was an HTML and a .js file. I saved them right to the desktop, but the JS is like a script file or something. I'm not exactly sure what it is.
Christian, you can do that from the tin files or from the 3D?
I don't know if Tin can do it or not. Maybe. Let's look. right here under web. Probably is the same thing. This one's probably a solid surface. Yep, so this one's a solid surface. Okay, so we have single beam editor, we have HYPACK, we have the cloud program. What about volumes? Can we run a volume against this set of data that we kicked out of the single beam editor? Sure. So we've got, before I get there, I'm going to kind of explain what we've got over here as far as a template. Who needs help with templates and channel designs and stuff? Everybody? Okay. All right, so I'll focus on that, and that'll probably take us to the very end where we're actually computing a volume. This job here, luckily, is pretty straightforward. We'll turn this CAD file off. I don't want to confuse you. I don't want to have the screen too busy. So I'll just have something like this up here. Maybe turn that plotting sheet off too. But Travis has gone ahead and made this in the advanced channel design program. All right. So the owner had given him a set of points that define the channel, and he's gone into preparation, editors, advanced channel design. And I'll just explain real quick. There's another volume class, but I'll explain advanced channel design and then the basics on how it works. So it looks like this Wiggins pass is the CHN. Okay. So a CHN file is just really nodes, faces, and zones. You have to start your file off with nodes. You can type this in, but I recommend getting a point file. And you can import a point file right here by hitting this white piece of paper, this new button, and then hitting the open folder and browsing to any type of file format down here. And usually it's an XYZ. You can do a DXF 3D face file. But if you just have an XYZ file, this is real helpful. Just to bring that in as XYZs and then make your own faces. But once you bring in that point file, you're going to have your list here, and you'll have an elevation for each point. And it'll highlight each point that you click on. Okay? Each point has an ID as well for identification. And then the way these faces work are a little tricky. Wish it wasn't this way, but it's this way. If you're in depth mode, these faces need to be made counterclockwise. If you're in elevation mode, it gets made clockwise. I wish we'd get rid of that logic, but that's just the way it is. So if I look at nodes 1, 2, and 9, Florida Dredge is in elevation mode, so he's gone clockwise. 1, 2, and 9. 1, 2, and 9. So that's the right way to go with that. There's
So what would happen if some other dredger was in depth mode but they went clockwise?
You can fix it with this button right. Well, you have to define what mode you're in. This arrow right here sets the mode. If the arrow is going up, you're in elevation mode. If the arrow is going down, you're going to be in depth mode. So by clicking this button right here, this circular button, fix orientation, it looks at this button, and if you click this and made it the wrong way, it'll fix it. It'll put them back in reverse order. So, I think, yeah, okay. It actually worked. So I go back to elevation mode, and then I'll do it again, and I'll flop it in the right way. Okay? You can also hit this button right here to check your faces. This just shows you any type of error. Some people will make vertical walls in their CHN file. And if you have vertical walls in your CHN, it'll tell you here when you run a check. It's not an error. It's just saying, hey, look, fella, you got vertical walls. And the reason it's telling you that is HYPACK doesn't run any volume against a vertical wall in 10 model. So really it's just a box cut. The volume will be limited at that line where it ends on the bottom. Does that make sense? So that's something that you're going to want to check. So nodes, faces, check your orientation, and then I would take it one step further. I would go to the zones. Doesn't look like there's much slopes. There's very much of a slope on this side. Let's see, 7 feet. What's the distance? You know what kind of slope that is? Let's see. Let's see what the distance is. Two feet? There's really no slope at all. Yeah, it's almost like just a vertical wall. Okay. Anyway, keep moving on. Zones. I like the zones because when I run a volume, I can run volume versus a zone, and it'll break out the volume. We'll pretend this is inside the pass over here, inside the inlet, and this is just outside the inlet. So I can make a zone for each one of those areas, and I'll add 2 here. I'll make this inside and outside zones. And then I'll click on the first one and I'll define it. So this area here is inside the pass, and this one here is outside the pass. So from here, I'll just simply save it out. Try that one more time. Okay. So now I've got that new CHN file with zones. And change the transparency of it. So now it turns into a nicer chart to display on the screen. And not only that, when I run the volumes, it's going to break out the volumes by zone. So to do that, I'm going to go into the final products and then 10 model. I'm not going to use the pre-survey. I'm going to use that set of XYZ data that came out of the single beam 64 program, and I'm going to run a volume of the points that came out of the single beam editor against this CHN file that I created in Advanced Channel Design. So to do that, I'll go File, New, and my main input file is the first 2 days of dredging XYZ, and then under the channel file, I'll choose the Wiggins Pass with zones that I made. Okay, you just hit OK, and the first thing that I do is check that the data is there, and now I can go calculate volume and do a 10 to channel. And if we've got any over depth, I can include that as well. And itemize by channel zone. So I'll run the volume, took just under 2 seconds to compute, and now I can look at the volume report. Okay. So the volume report will tell me the 2 files that I used to compute the volumes. It was the first 2 days of dredging XYZ and the Wiggins Pass CHN channel zones. Okay, so there wasn't a lot of material removed this day, Travis, from what I can tell. But down here, it tells me the zone volume inside the pass at 136 cubic yards removed, and outside the pass was 32 cubic yards for a total of 168. Then you can add your over depth, and that's the total removed for that day. Okay. So that's a great deliverable. Now, is that an accurate volume? Probably not. You probably need to get that survey boat out there and take some soundings and verify, because this is only going to be as accurate as the calibration that you have of your dredge. Okay. Is there any questions on that? Is there any questions in general what we've gone over so far? Okay. Okay. What other reporting things do we have in HYPACK? What else are you responsible for turning in?
DQM.
The DQM. Okay, that's great. So, who has DQM responsibilities? Most people do now or eventually will for all types of dredge. Bobby, do you have DQM on your clamshells?
I do, we don't turn them
Okay, good move. Okay, so depending on the type of dredge you have, you're going to have a DQM driver attached to your hardware profile. So the requirements for DQM are laid out specifically in their specifications, and just to sum everything up, they're JSON files. It's a pseudo XML file that gets transmitted as work events to the Corps of Engineers on a 6-second interval, no more than 6-second interval. So all this data gets compiled in the Irvington U.S. Army Corps of Engineers office in Alabama. So there's a big room like this, there's screens everywhere, and they're monitoring all the dredge projects. So just to give you an example, and I'll use Bobby's example because he used clamshell dredging. In his hardware profile, he's got a DQM mechanical driver probably loaded. DQM mechanical right here. Okay. And what this driver does, see if it tests out here. This is a little sluggish in hardware, so just bear with me. I want to get to this DQM data tab. Okay. So for DQM mechanical, once you specify what your contract number is and the scow information or the barge information, the scow trip number, the project trip number, and all that good stuff, when that gets updated, it updates the JSON file that gets transmitted for the clamshell bucket type of DQM. Close this down. I'll go into the inclinometer one. Okay, so this one would be for a cutter suction dredge, and it's got all the information. It's got all of these data items right here that get output. So you have all the vessel information, X and Y. Actually, this is hopper stuff right here. So you've got the port head and starboard head information, the displacement, the tide, and all that stuff is what the Corps wants. So that kind of runs in the background. So without getting into the nuts and bolts of how the DQM drivers work, I want to take you to the folder where this stuff exists, because that's what you're going to eventually turn in. And I have a project here, my favorite project in the world, my Key West project. Okay. It's got this folder called inspector data, and I think it's the same for Uquina and maybe for Manson on your hoppers as well. Is this, and for anybody for cutter suction or mechanical clamshell dredging, this folder right here contains all the load data. Okay. So by day, it saves the file in a few different types of formats. Oh, I don't have anything in here. Oh, I have a CSV in here. I'm not sure. There should be a JSON file somewhere in here. So while I'm talking, I'm going to go ahead and search for a star.json. Okay. So if I open this CSV file, I can see it's probably got all of these parameters that it was supposed to log. This is all the information that the core wants right here. It's all of the displacement, pump speed, pump RPM, gimbal location, drag head location, etc. So that's where you'll find that stuff. So what happens a lot is we'll get a call and the customer will say, well, the Corps of Engineers just called me and they haven't been getting our data. How do I turn that data into the Corps of Engineers? Because automatically it's supposed to just send through the internet to them. But that folder there, you can go and get those files and email them.
Yeah, if we ever don't, if the other thing gets sent through, what we usually send, of course, the XML file.
The XML works fine. Okay.
Yeah, that's what they ask for.
Yeah, because the JSON file are just work events sent out at an interval.
Yeah, they want the XMLs if it doesn't go automatically.
Right. Okay, so that's pretty much all I got for dredge reporting, unless you want to have a general discussion about dredging or anything HYPACK. Here.
I just have a couple public service announcements that I forgot to do yesterday.
Absolutely.
Real quickly, for our Army Corps colleagues, we are having our Army Corps HYPACK meeting. It'll be at 5 right after the Q&A in the main conference room. And then the other thing I forgot to mention is Norbit does have a vote for demo. So if you want information, stop by the Norbit exhibit booth and talk to them.
I haven't done this yet, but I got a job coming up, so I have the XYZ, which I turned to a matrix, and they want it, it's all over the place, but they want it 4 feet deeper than what it is.
Okay.
So if I take my XYZ, put in export, and I add like a 4-foot difference and make everything 4-foot different, can I turn that into a matrix and add it as a channel file in Dredgepack?
Right. So
So I can't do that.
in Dredgepack, on your chart channel where you load your template,
Right.
just change the file type from CHN to MTX, and now
That's it.
that's your template.
Okay. I thought you could, I haven't done it yet.
I use matrix file as a template pretty much for everything. And as a matter of fact, while I'm in here, we find a practical way to explain this. Okay. Okay, here's what I'm going to do. I have this XYZ file. I'm just going to use this as an example. This is going to be kind of an absurd example. I'm going to take Travis's data, this XYZ file of what he dredged. I want that as the template. The owner says, okay, I want that to be the template minus 2 feet. I want you to go 2 foot deeper, and I want you to dredge that area 2 foot deeper. It needs to be the template. So I'm going to take that XYZ file, I'm going to take it through the export routine, and I'm going to drop it down 2 feet. That's the only file that I'm going to check. So this is going to be a 2 foot deeper. Then I'll go into the options and I'll set a Z offset of 2. And then I'll convert it. So what it's done is it's taken this set of XYZ data and just dropped it down.
Elevation.
What's that?
Elevation.
I'm not worried about that right now. I'm not going to confuse everybody. It would have been a minus. So what we'll do here is with this XYZ file, I'm going to go Final Products, tin model, and I'm going to give you an example of a CHN out of 10. So tin model, if you go File, Save, I can take this XYZ and save it out as a CHN. Let me change this. Okay. So under File, Save it as a CHN. So this is going to be my tin channel. So tin model just saved out a CHN for me. And it looks like a hot mess. Okay. Would I want to use that in Dredgepack as a template? No. I think there's too many triangles. I'd have to ask programming, but my guess is a few 500 to 1,000 faces is kind of the maximum that you can load into Dredgepack. Anything more than that, I think it tells you too many faces. And look how many faces this has, because this CHN file came from an XYZ file. But I can still, I should have really edited this surface and got rid of some of this stuff. Everybody knows how to edit a tin, is that right? Nobody knows how to edit a tin? Okay. So if I want to get rid of some of this stuff that's on the fringes, in the tin model program, when I go to the tin editor, I can use some of these tools to modify the surface. So I usually use this polygon pen right here. And it's just a really easy way to clean the surface. A little nicer to look at.
Can you add a border file right here?
You can. You can add a border file right here. So now I'll save that out. It's going to be a little prettier picture, a little prettier CHN. I'm just showing you little cheat codes. All right, so I need to use this as my template. If you're doing environmental jobs, they're all going to turn into this type of template eventually anyway. They're going to have you dredge to a surface based on the existing bottom contour, drop down a level, like probably what you're doing. So to get this into a template format, I need to open the CHN file in Advanced Channel Design. I clicked on it. There we go. Let's go ahead and open that. It's counting down the progress. A lot of faces in here. If it's a really large area, hit the button and go to lunch. It'll eventually finish. I didn't look to see how many. I guess while it's running, I can see how many triangles it made. So this has got 105,000 triangles based on 55,000 points. See where we're at. Hey, we're at 35%. We'll let it run. Okay, so while that's running, is there any other reporting requirements that you have for the dredging? No?
Listening about reporting requirements.
Okay.
But Dredgepack, if you have a defined channel with already a center line and tows, or just a small waterway, well, sometimes in smaller dredging operations, they request a center line and channel file over the cut block.
Okay.
But I want the chainage to reflect, of course, what the channel is. Is there an easy way to offset my center line, like maybe 10 foot, and refine the channel with the correct chainage?
Yeah. Yeah, how did you make your line work in line editor or like in channel design?
It's just an LW file,
It's an LW file?
but there is a channel also file, or PL.
So the easiest way that I would do is I would extend the line or shorten the line, depending on which way you want to go. You want to add distance to your stationing or subtract distance from your stationing, and just lengthen the LW. So the line editor program will let you extend the line. And if you just type in a number, say your line is 100 feet long, and you make your station about 5 feet, you put in extend line 5. If you wanted to shave off 5 feet, 95, you put in -5 on the extended line. Does that make sense? I'll show you. This is still 62%. Okay. Let's get rid of this matrix. Okay, so I have a planned line here, which is my baseline. This line is 1,445 feet long. So it's deriving station 0 plus 0, 0 off this, right? So in your case, you're off because this line is starting at 0 plus 0, 0 somewhere incorrectly.
Well, I mean, they're going to be maybe 5,000 feet north
Okay.
of where the actual channel starts,
Okay.
but their cut block is starting at 5,000. I want it to reflect the 5,000 just in the cut block, and that, which is off-center from the because this is a 300 to 350 foot wide channel. So I just want to offset my center line, cut it, and then rezone a cut block for them so they have a center line, which I do for them anyway, but I actually draw a line and then match it, do a line intercept calculation to my plan line.
That sounds complicated.
It is complicated. That's why I was trying to find a quick and easy solution.
Yeah, there is a quick and easy solution because I don't do anything real complicated. You have to show me what you're talking about. Like if you have a project, I'd love to see it. Or if you've got it right now, we'll work it up.
See if I can pull it up
Yeah,
on the drive.
I'll give you a flash drive. All right, let's see if this channel file. 78%. I'm on
We've got
it.
another one too. Some projects want daily plots of the disposal plots.
Okay.
The way we handle it is we send the CHN file into our waterways, and they've got a program that pulls it out in plots and sends it to
Oh, no kidding.
the, yeah.
What they have, George and Carlos can probably tell you, is they've got a driver in HYPACK hardware
The
that wants
massive
that.
driver.
Yeah. You guys use the same thing?
Yeah, we've got that driver too. And, I forget there's I can't remember now exactly what was happening with that one. It's mostly California that they didn't like.
Okay.
Or it could be that the SCS doesn't use Dredgepack and they're trying to be consistent between the two.
Yeah, I don't know. Does that driver work?
Yeah, can you speak to that, Terry?
I'm sorry.
Yeah, talking about the, some of the projects require the daily dump plots. Yeah, and I was just saying how we send them into CHN files and you guys extract those and send them to the projects. Do you do that because the SNF uses a different program and you're trying to be consistent between the two?
Yeah.
Oh, okay. That was it.
Hey, we're at 90%. All right, so while this is ticking away, well, this is already loaded. Okay. You have to start off with a matrix, first of all. So we're trying to turn a CHN file into a matrix for a template. Everybody gets that part, right? So what you have to do is you have to build a matrix box around your area. So you use the matrix editor. Oh, that's a big box. Here we go. So you just simply make a matrix box around it and then save it out. Okay, just a blank matrix. You've got your advanced channel design with all these little triangles in it, nodes and faces. So if I want to save this out as a matrix template, really? It's recording, good. Oh, that's embarrassing. Okay. Sorry. There we go. So I've got the matrix boundary, and all I'll do is go to the Save Diskette and change the file of type down here to matrix. And then overwrite the matrix that you just made, and it will fill all the cells with the depth data. So dredge template, replace it, and now you'll see here it's 1 kilobyte. Starting to build, you can see the file size is getting a little bit bigger. Same thing for you, Ken. If you're doing conditional surveys, you can load a template right into a survey program under chart channel and load the CHN or load a matrix template, and then have your new depths update the matrix and show the channel template at the same time, so you can see the high spots right away when you're surveying the dredge.
I like that HTML 3D because when you can mark off high spots and other cells.
Oh, okay.
The other, you can look at it from this way, from that way, so
Right.
you can do it 3D. That's awesome.
See how well it did. we go. So now there's the matrix template. It's a 5x5 matrix template. Pretty simple.
So you could have clicked that to a order that you made up from the channel.
Yeah. Yep. So the moral of the story is, matrix files and CHN files, you can go between them. Unfortunately, you got to get 10 involved, to some degree. Okay. Is there any questions?